Hi and welcome to video 5. This is the 5th of 5 videos for sections 3.7 for Math 181. In this video, all I'm going to be doing is working examples out of the book. So maybe if you're working the homework, maybe you understood most of the chapter and this is the only video you need to go to. If there's a problem that's got you stuck and you just need some help, or you need to see hopefully another type of that problem worked out, hopefully I cover it here. We're going to be doing 4 of them in this video. So what I would suggest is maybe if you're following through and you want to try them out, pause the videos. Once I give you the problem, try to work them through, see what you get. If you get stuck, then hit play and catch up to where we're at. So the first one, I'm going to start out. Got to crawl before you walk, walk before you run, right? So we're going to start out with number 1. Pretty straightforward example. Limit as x approaches 1 of x squared minus 1 over x squared minus x. So if I plug in 1, what do I get? 1 squared is 1. So I get 1 minus 1 in the numerator. 1 squared is 1 minus 1. So I get what? 0 over 0. This is one of my indeterminate forms. I can apply L'Hopital's. So this is the limit as x approaches 1. Take the derivative of the numerator. X squared, if I take the derivative of that, is 2x. Minus 1, that's gone. And then 2x minus derivative of x is 1. So I end up with 2x over 2x minus 1. Plug in 1, I get 2 times 1 over 2 times 1 minus 1, which is 2 over 2 minus 1, or 2 over 1. So my answer is just 2 in this case. Let's look at number 15. And again, I don't want to rush through these necessarily. When I put the problem up, I'll even give you a second here if you want to hit pause. Try to work it through. If you get stuck, well, that's fine. And just hit play and catch up to where we're at in the problem. So let's say we have the limit as x approaches 0 of x to the 3 to the x power all over 3 to the x power minus 1. So it's a little different from anything we did in the previous videos. Combines a few different things here for us, but let's plug in 0. What do we get? X is 0 times 3 to the 0, so 3 to the 0 is 1. Anything to the 0 except for 0 is 1. So again, 3 to the 0 here is 1, minus 1, so I get 0 over 0. So that's good for me. It's already in the indeterminate form. I can just apply L'Hopital's here. So the limit as x approaches 0. In the numerator, what do I have? I have a product. So I'm going to have to do product rule on here. So it doesn't eliminate all that necessarily. I'm just not doing quotient rule on this whole thing here. So if I take just the derivative of the numerator, it's a product, x times 3 to the x power. So derivative of the first is 1 times the second, so 3 to the x, plus the first, x, times the derivative of 3 to the x. So if you remember back in our in our exponent videos, when we have a number to like a to the x power, that's what? Well, that's a to the x times the natural log of a, which in this case is 3. So the derivative of 3 to the x is 3 to the x natural log of 3. So same thing here, 3 to the x is 3 to the x natural log of 3. And then minus the derivative of 1 is 0. So now let's go ahead and plug this in. So if I plug in 0 here, 3 to the 0, anything to the 0 is 1, plus x is 0 times 3 to the 0 is 1 times natural log of 3. So this whole thing is what? This is just equal to 0. As long as I didn't have an infinity in there or something, I'm okay. It's just a bunch of numbers after 0, so that's 0. And then in the denominator, 3 to the 0 is 1 times natural log of 3. So I get what? I get 1 in the numerator. 1 plus 0 is 1. and 1 times natural log of 3, so just natural log of 3 in the denominator. So that's my answer. So the limit as x approaches 0 of this function is 1 over natural log of 3. All right, third example, number 25. So we have the limit as x approaches infinity of x to the third times e to the minus x squared power. So if I plug in infinity, infinity to the third power is infinity, and this guy is what? E to the minus x, this is the same as 1 over e to the x squared, right? If I move that to the denominator, this becomes a positive exponent. So if I plug infinity there, I get 1 over e to the infinity. So e to the infinity, this whole thing is going to basically be 1 over infinity, and 1 over infinity is what? It's basically going to 0. So this is infinity times 0. So this is one of my indeterminate products. So I need to move something into the denominator, and I sort of gave it away here. And again, there's no right or wrong which one you move to the denominator. Sometimes one way is easier than the other. But here, and you can kind of use this as a hint, if you have something that already has a negative exponent, try moving that one to the denominator. Then the exponent becomes positive, and you don't have to work with all the negatives in the problem. So I'm going to rewrite this guy as what? Limit as x approaches infinity, leave the x to the third in the numerator, bring this guy to the denominator, but I have to put it in its reciprocal, right? 1 over e. Oh, yeah, so this is 1 over e to the minus x squared. So I can rewrite this as well, right? So this one, if I want to get rid of that negative exponent, I can just bring that to the numerator here. So this is e to the positive x squared. So when I brought this guy 1 over that into the denominator, I can make this positive by bringing it into the numerator of the fraction that's in the denominator. I know a lot of talk here. Hopefully I'm not confusing you. So this piece here is really the same as x to the third over e to the positive x squared. And that's why I said if you have a negative exponent in the start, bring that piece down and it'll change it for you. So now if I test it again, plug in infinity, well this is what? Infinity in the numerator, all over e to the infinity squared is infinity. So now I can apply L'Hopital's. So this is the limit as x approaches infinity of the derivative of the numerator. Derivative of x cubed is 3x squared. Derivative of the denominator is what? Well, derivative of e to anything is just e to that again, x squared. But then you need the derivative of the exponents. The derivative of x squared is 2x. So now, one of these x's in the denominator, the 2x, that x will cancel with one of these. So I'm left with 3x over 2 e to the x squared. So if I plug in infinity, 3 times infinity is infinity. E to the infinity squared is infinity times 2. Well, I have infinity over infinity, which is okay. Why? Because I can just apply L'Hopital's again. So now I'm going to apply L'Hopital's. The limit as x approaches infinity of 3x is in my numerator. And what do I have here? 2e to the x squared, just cleaning it up a little bit. So that's the limit as x goes to infinity. Derivative of the numerator, derivative of 3x is just 3. Derivative of the denominator, well, it's what? It's e to x squared again, times the derivative of 2x, derivative of x squared, which is 2x, times the 2. So I end up with 4x e to the x squared in the denominator. I'm not going to spend a lot of time going through how, if you can't figure out that derivative by now, that would be a worrisome sign. So you should be able to figure out the derivative 2e to the x squared gives you this guy here. Right? Yeah. So now plug in infinity. I get what? 3 in the numerator. Infinity, because it's 4 times infinity times e to the infinity squared. So 3 to the infinity, 3 over infinity, which is 0. So the limit of our initial example goes to 0. All right, I'm going to erase the whole board here. This last example is a pretty long one, so I want to have the whole board available to us here. So if you need any of this, go ahead and hit pause. Otherwise, I'm going to erase both these problems, and we'll look at the last example, which is number 36. And I chose this problem specifically because I know it's one of the WebAssign problems, and it's a bit tricky. So I wanted to do it for you, obviously in a typical flipped classroom format. We would probably do this problem in class, right? People would come in, I'd say, okay, any questions? Yeah, I'd like to see number 36 or whatever problem it is on WebAssign. So number 36 from the book is the following. We want to find the limit as x approaches infinity of 1 plus a over x to the bx power. So right away, this should send off some bells and whistles saying, uh-oh, exponent, this is probably my indeterminate power problem. So let's check it out. If we plug in infinity, what do we get? We get 1 plus a, which is just some random number, over infinity. So any number over infinity, this is what? This goes to 0, all to the b times infinity, which is what? Also infinity. So 1 plus 0 is 1. So we get 1 to the infinity power. So sure indeed, this is one of our indeterminate power problems. So what do? We're going to use e in natural log. We're going to rewrite this guy. So it's the limit as x goes to infinity of e. I bring down the exponent piece, bx, natural log of whatever the base was before, 1 plus a over x. And now remember, with these, my only concern, I'm not doing the derivative of this whole thing. Well, let's actually plug in infinity to see, can we use L'Hopital's on this guy, or do we have to do anything to it? So if I'm looking at just the exponent piece, and I want to know what is that trending to, or what is that approaching as x approaches infinity. So I'm trying to figure out the limit as x approaches infinity of this guy, bx times natural log of 1 plus a over x. So I get b times infinity, so that's infinity. And then natural log a over infinity, that's 0, so natural log of 1 is 0. So that means this piece right now is infinity times 0. So that means what? This means I have an indeterminate product, and I need to use that methodology. So I'm going to have to move one of these into the denominator and take the reciprocal of it. So I'm going to take b times x, because that certainly looks a lot easier to me. So if I do that, I'm going to rewrite this thing as leave the natural log piece in the numerator, all over 1 over the first function, bx. So now I have what? I have 0 over, so let's do that. If I plug in infinity, this is natural log of 1, which is 0 again, all over, if I plug in infinity here, I have 1 over infinity, which is trending or approaching 0. So this is now 0 over 0. So now this is the function that I can apply L'Hopital's rule to. So let's do that. So I want to take the derivative of the numerator. So that's what? It's 1 over this piece times, have to use the chain rule here, the derivative of this guy here. Derivative of 1 is 0. Derivative of a over x, well, that's derivative of the top, which is 0, times the bottom, minus the top times the derivative of the bottom. So that's minus a in the numerator, all over the bottom squared. So that's what I get in my numerator when I take the derivative of natural log of that piece. In the denominator, it's quotient rule. So I get what? I get derivative of the top, 0, times the bottom minus the top, 1, times the derivative of the bottom. So derivative of the bottom, so minus that is, so minus b all over bx squared. So now I want to simplify that mess a little bit. So I got limit as x approaches infinity. So the numerator, I get what? Minus a over 1 plus a over x times the x squared piece. In the denominator here, so I'm going to keep change flip. So I need to bring this piece, I'm going to flip it over and multiply it by the numerator, so that means I get minus b in the denominator. And then here I have bx squared, so that's like b squared and x squared, if I take it out of the parentheses. So now let me start simplifying this. Well, this x squared here cancels with that x squared. One of these b's cancels with one of those. Negative divided by negative, so those basically turn each other positive. So I'm finding the limit as x approaches infinity of what? ab in the numerator, and all I have left in the denominator is 1 plus a over x. So as x approaches infinity, a over infinity, this guy is basically going to go to 0. So this goes to ab. But remember, with this kind of problem, like I tried to warn you in video 4, this initial limit is not going to a times b. This initial limit's going to what? E to this power. So I really need to take this guy, plug it back in here, because the limit as x approaches infinity of e to this guy, well, this guy is going to approach ab, so my answer is really e to the ab power. That's what this limit is going to as x approaches infinity. So that's it. 4 examples, hopefully enough of them between the instruction videos and then the problem videos here that if you do have homework problems, you're able to kind of get some helps and hints. If not, you guys, a bunch of you have my email. You can always send me a screenshot or something. If not, if you're not one of my students or you're following the videos on YouTube, leave a comment. Maybe I can try to help you through there. But otherwise, that wraps up the 5th video of these 5 videos. So good luck with this. Come on back and we'll look at the next series of videos.